Hi guys, I had a couple of requests to go over some of these problems for the test remediation. So I'm going to start with number 3, which is dividing. So when we're dividing by a single termed monomial, like what we have here, that 9r squared, we're going to take the full polynomial and we're going to divide each term by 9r squared. So I'm going to do this individually. So I'm going to take 9r squared and divide that into each of these terms. All right, so when we do this, I'm going to start with just my numbers. 45 divided by 9, well, that's easy, that's 5. Now, when I'm dealing with the variables, the rule is we want to subtract the exponents. So 4r's minus 2r's is going to give me r squared. All right, now I'm going to come over here. I'm going to do 27 divided by 9. So 27 divided by 9 is going to give me that positive 3. R cubed divided by r squared means I'm going to subtract 3 minus 2, which just gives me 1. So r to the first power. I don't have to write that 1 there. 9 divided by 9 is just 1. R squared divided by r squared means I'm going to do 2 minus 2, which is 0. That means that these r's cancel each other out, and we are now done. Okay. Let's do another one. So here's a problem where we already have it written as a fraction. So what I'm going to do is I'm going to take each one, maybe, hold on. All right, let's try that again. All right, so I'm going to take each one of these, I'm going to divide that. I'm going to divide those. And then I'm going to divide those. All right, so let's start with the 45 divided by 3. So that's going to give me 15. Now we got x to the 5th, and I didn't pay attention to what was on that x, so I actually need to kind of delete some of this. Okay, it's just a plain x. Okay, so x to the 5th, and that's really an x to the 1st. So x to the 5th divided by x to the 1st is really saying 5 minus 1. So that would give me x to the 4th. All right, now I'm going to do the next one. I had positive 9 divided by 3, so that gives me 3. X to the 4th divided by x to the 1st, I'm going to do 4 minus 1, which is 3. 36 divided by 3 gives me 12. X squared divided by x to the 1st means I'm going to do 2 minus 1, which is just x. And now we're done. So that's our final problem, our final answer. Okay. I'm going to scroll through these, see if there's any others that I think would be good to go over. All right, I want to go over this one here, number 6. I'm going to touch on number 6 really quick. All right, so when we do number 6, same thing as what I just did up on number 2. So I'm going to take this first term, divided by 4v. So 20 divided by 4 is 5. Again, this is v to the first power. So v cubed divided by v to the first, 3 minus 1 is 2, so v squared. 8 divided by 4, 8 divided by 4 is 2. V squared divided by v to the first, 2 minus 1 is 1, so just v. Right? 4 divided by 4 is 1. Whoops. Hold on, let me fix that. All right. So 4 divided by 4 is 1. And then v divided by v, well, that's also v to the first power. So 1 minus 1 is 0. So those v's just cancel each other out. So we just have a 1 there. And then that's your final answer. Okay? Now, when we go over to the next page, Now we're going to divide a trinomial by a binomial. So the first thing we have to do is factor out this first one. Right? That's the first thing we need to do. We need to factor this out. So the first thing to factoring is we look for a greatest common factor. So a GCF between 2, 9, and 10. I don't have one. There is no GCF for 2, 9, and 10. So now I'm going to go to my magic X. So I'm going to do 2 times 10. We remember how to do this? So that was 20. My middle term, negative 9, goes here. I need two numbers that will multiply to 20, add to negative 9. All right, so I don't have this up right now, but let's do this. Let's go to our Desmos. Right, and we can actually find that greatest common factor in our Desmos. So we can pull up the keyboard, and we can come over here to Functions, go to Miscellaneous, and the greatest common denominator. And we need to find, oh wait, nope, never mind, that's the wrong thing. That was GCFs. Can we find the factors? Oh, we can. We can. All right, I need to make a table. Nope. Hold on. How do I? Oh, add. That's right. Okay. So I want to do. Hold on. Sorry, guys. It's been a while since I've done this. All right. Try this again. I'm going to do x1. No. I'll get this eventually. All right. We had to find factors of 20. So I'm going to do 20 divided by x1. And now I can go ahead and I can insert. It's not going to let me insert my table. Alright, maybe I can't do this with Desmos easily. Alright, I will see if I can come up with how to do that in Desmos. I can't remember how to do it. So we'll see if I can come up with that and I can make another video for that one. Alright, so in the meantime, factors of 20 that multiply to negative 9. So I can do, so factors of 20, I've got 1 and 20, 2 and 10, 4 and 5. Alright, well it has to multiply to a positive number, add to a negative number. So that means if it's multiplying to a positive, these both have to be the same sign. So they either both have to be positive or they both have to be negative. In order to add to a negative number, that means they both have to be negative. Alright, so same signs, I have to add my two numbers together. That's going to be these two here. 4 plus 5 gives me negative 9. So negative 4, negative 5. Alright, so now I can go ahead and erase this. Now that we've got that part, now I can go ahead and I can make my box. So if you remember, oops, the little thing keeps getting stuck here. Sorry about that. Let's try that again. Alright. Okay, so we're going to put our first term here. So, oh, I think I know what's going on. All right, so 2p squared here, my last term here, and then we split up the middle term here, so negative 4p and negative 5p. All right, now that we have that, now we look for our greatest common factors. Remember, we're always going to have a p here and a p here, always, or x, or whatever variable happens to be. Now I look for my greatest common factor between 2 and negative 4. Well, that's a 2. Between 2 and negative 5, that's just a 1. All right, between negative 4 and positive 10, that's a negative 2. Between a negative 5 and a negative 10, that's going to be negative 5. All right, so now I've got my factors. So this here can be split up into 2p minus 5 and p minus 2. All right, just to give me some space, I'm now going to erase this whole thing. All right, so now we've got our two factors, 2p minus 5, p minus 2, and we're going to divide that by 2p minus 5. What you should notice is that two of those are the same. This factor here and what we're dividing by are the same. It means they're going to cancel each other out, and what we're left with is our answer. So p minus 2 is our answer. When we do this one here, first thing I'm going to do is factor out a greatest common factor at the top, and in this case I can actually factor one out of the bottom. I'm going to tell you on your test you're never going to have to factor one out of the bottom, but I'll just show you how to do this one. Alright, so I can factor out a 20, and then I'm left with x squared minus 4. Now this one here, if you remember those patterns, is a difference of perfect squares, which means that can factor more. So I've got 20, and then I end up with x plus 2, I ran out of room. Let me try running a little smaller. Alright, so 20, and then we said x squared minus 4, which can then go to 20. X squared minus 4, it's a difference of perfect squares, so take the square roots of both of those. So the square root of x squared is x, the square root of 4 is 2, so x plus 2, and then x minus 2. So that was factoring a difference of perfect squares. This one here, I can divide them both by 4. So now I can divide this by 4 and r minus 2. And I goofed, those x's should be r's. Alright, so now we should notice that this, remember that's supposed to be an r, not an x. By habit I did x, so r minus 2 are the same. But we can also simplify this 20 and the 4. So 20 divided by 4 is actually 5. So we're left with 5, r plus 2. So like I said, this one was more complicated than what you're going to see on the test. You're never going to have to factor the bottom in Algebra 1, just the top. So number 13 is another difference of perfect squares. K squared is a perfect square, 36 is a perfect square. So you don't have to do the magic X in the box if you don't want to, although you can. So again, remember your steps to factoring. 1, look for a GCF. 2, if it's not a difference of perfect squares, you do your magic X. And then your box. Okay? Alright, now let's come over here. So this one is just factoring. Okay? Just factoring. So first, all they want you to do here is factor out the common factor out of each expression. So I'm going to start with my numbers. If your first term is negative, then your common factor has to be negative. So the biggest number that can divide into 10 and 15. This is where I can use Desmos for sure. Alright, so if I want to find the greatest common factor of, what was it again? I forgot. 10 and 15, or negative 10 and 15. We're just going to do the 10 though. Alright, I'm going to pull up my keyboard. I'm going to come over here to functions, and I want the miscellaneous. I'm going to do GCD. Now I can do 10, comma, 15. And then it'll tell me right here that my GCD is 5. So now I'm going to come back over here. Since this was negative, I have to be able to pull out a negative 5. So I know that I'm going to pull out a negative 5 from both. My greatest common factor is going to be negative 5. We have to look at the variables as well. They both have ends. I look for the smaller one. That's going to be my GCF for the variable. So negative 5 n to the 9th. So I'm going to divide everything by negative 5. Whoops, what am I doing? Let's just start that over again. negative 5n to the ninth, and I can divide this by negative 5n to the ninth. Alright, so now I can do negative 10 divided by negative 5, and when I'm factoring, that greatest common factor has to be part of my answer. So negative 10 divided by negative 5 is 2. And then remember we subtract our exponents. 11 minus 9 is 2. So 2n squared. 15 divided by negative 5 gives me a negative 3. 9 minus 9 is 0, which means that the ends cancel out. This is my final answer. We have to make sure that we include the greatest common factor in our answer. I'll do one more. I'll do number 4. So when we're looking at one like this, we want to find our, actually I'll do one bigger numbers. No, I'll do a couple more. Alright, so my greatest common factor here. Oops, I don't know why I made 2 G's. Alright, my greatest common factor here between 14, 14, and 7. So again, if you're not really sure, I can come over here and we can go ahead and delete. And I only have to type the 14 in once, and 7. So the greatest common factor was 7. So we can come back down here. So we know we have 7. Now, my smallest r was r squared. So r squared. So now I'm going to divide everything by 7r squared. 7r squared, 7r squared, 7r squared. Alright, 14 divided by 7 is 2. R to the 5th divided by r squared is r cubed. 14 divided by 7 is 2. R cubed divided by r squared is just r. Negative 7 divided by 7 is negative 1. R squared divided by r squared, 2 minus 2 is 0. And then we don't want to forget to include our greatest common factor in our answer. Now, just to show you that we can find greatest common factors of bigger numbers, and in this case they want us to fully factor. Or no, this one was, again, just greatest common factors, right? Yep. This is all just greatest common factors. So I want to find the greatest common factor between these 3 numbers. Those are some bigger numbers, so I'm definitely going to utilize Desmos for this, and you may use Desmos on your retake. So I have 64, 80, and 56. So 64, 80, and 56. So 64, 80, 56. What's nice about Desmos is I can put all 3 numbers in at once. And I remember on the graphing calculator we actually had to do that GCD twice before we could start typing numbers. In Desmos, we can just do it once, all 3 numbers show up. My greatest common factor is 8. Alright, so now I know I can come over here. My GCF is 8. I look at variables. I have b squared, b, and then I have no variable. So since this one does not have a variable, b cannot be part of my greatest common factor. So I'm just going to divide everything by 8. 8 is part of my answer. 64b squared divided by 8 is just going to be 8b squared. Negative 80 divided by 8 is negative 10b. And 56 divided by 8 is going to be 7. Done. Alright, now let's take a look at just the factoring on the other side, which is more of what we did from the division, because we had to do some factoring when we divided. Alright, so difference of perfect squares, okay, a difference of 2 perfect squares. So I can go ahead and find the square roots of each of these. So the square root of n squared is n. The square root of 100 is 10. So my pattern is this: n plus 10, n minus 10. Done. Right. This one here, I'm going to do my magic x. So 1 times negative 24 is negative 24. And then my middle term, negative 5, goes at the bottom. So I need factors of negative 24 that add up to negative 5. Since this is negative, I'm going to have one positive and I'm going to have one negative. My bigger number is going to have to be negative since this is negative. All right, so factors of 24, we got 1 and 24, 2 and 12, 3 and 8. There it is, 3 and 8. Because 8 minus 3 is 5, or 3 plus negative 8, or 3 minus 8 is negative 5. Now I can go ahead, I can make my box. First term goes here, n squared. Last term goes here. And then my two terms, let's split the middle one, 3n and negative 8n. All right, so I'm always going to have a variable here and a variable here. Now I look for greatest common factors. There's a 1 and a 3, so just a 1 here. A 1 and a negative 8, so just a 1 here. 3 and negative 24 is going to be plus 3. Negative 8 and negative 24 is going to be negative 8. All right. Now we've got our answers. So we end up with n plus 3, n minus 8. What you might notice is if your leading coefficient is 1, we can actually skip this whole box because these guys right here are the same values that go here and here. That only works when your leading coefficient is 1. I'll do one more when your leading coefficient is not 1. All right, so let's just do this one here. So we're going to do our greatest common factor. So 42, 72, and 162. Let's see if I can remember all that. All right, 42, 72, 162. Greatest common factor is 6. All right, so I'm going to factor out a 6 first. So now I get, 42 divided by 6 is going to be 7m squared. 72 divided by 6 is going to be 12m. And then 162 divided by 6 is going to be 27. All right, now we can go ahead and do our magic x. So now I have to do 7 times 27 gives us negative 189. And then it has to add up to a negative 12. So remember, we're only using this trinomial here now. So negative 12. So I need to find factors of 189 that will add up to negative 12. Okay, so to find factors of negative 189, for now I'm just going to use my graphing calculator that I have here. If I can get this to work. All right, there we go. All right, so I'm going to do negative 189 divide by x, and then I can do second graph. So again, I'm going to try and find a way to do this in Desmos, and then I'll post that up. But for now, just to make this a little quicker, we can go ahead and do this. So we're looking for ones that will add up to a negative 12. So I'm going to kind of scroll through these. That makes negative 20. That one right there, 9 and negative 21, okay, will give me the negative 12. So I've got 9 and negative 21. Alright, now I have to make my box. Because my leading coefficient is not 1, I have to make a box. Alright, so my my first term, 7m squared, my last term, and then I split the middle, 9m, negative 21m. Alright, so again, I always am going to have a variable here and a variable here. Now I look for greatest common factors. There's none between those two. These two have a greatest common factor of 7. These two have a greatest common factor of 9. And these two have a greatest common factor of 3. Oh, negative 3. Since this is negative, this has to be negative. So now my answer becomes the GCF, 7n plus 9, and minus 3. Okay? So there's a few examples for you. If that helps, great. If you need more help, let me know, and we can check into my virtual classroom and I can answer any more questions that you might have.